Okay, so I think we have to start. We are continuing from where we left off. Now we have two main groups. So I kind of need to ask, or I need to find. Welcome and good morning once again to Cost and Management Accounting 1. And in fact, the particular topic we've been discussing all along for now is Python for Management Accounting. Today, we seek to conclude on that topic so that the following week or the following meeting time, we are going to start management accounting issues. The main thing we are trying to do is inside management accounting itself, there are a lot of things that we'll be doing, which are data processing matters, as we have already established. So when we get to the stages where we need to process some data for some particular task, we try to see if Python is applicable there, and we use Python to do that kind of implementation. The reason is, in the real world, I have already explained that kind of work you'll be doing around management accounting will be kind of dealing with a very huge data set, analyzing huge data set for insight to guide management decision making. And that kind of job or task requires you to have a tool which can make your life better. You can't do that kind of big data analytics with a calculator. I mean, you can't imagine doing that job with a calculator. So the reason why we've taken some time to take ourselves through Python for management accounting is just for that reason, so that we'll be able to deal with big data that's is in the realms of management accounting. We have dealt with the basics of Python, basically Python data types, Python data structures mainly, and most importantly, we have talked about some methods which are inherited by some data structures and how you can use the methods to manipulate and do that advanced data analytics on your data. We have talked about basic data structures like lists. I mean, list and tuple are very similar. We've discussed the circumstances in which you might prefer to use a tuple instead of a list. We have discussed dictionary. We've discussed methods which are applicable, and your textbook has very fantastic demonstration of the methods which apply on each of these data structures. The main data structure which we are kind of traveling to, we are doing all of these things, and where we want to arrive is that advanced data structure that we call data frame. The data frame is housed inside a package called pandas. And The reason why that is where we have our eyes is that Pandas data frame is designed such that it has a lot of fantastic methods which apply for advanced data analytics, right? So it's very important that you take some time and go deep into data frames, most particularly the methods, a lot of methods, and the internet is a good teacher when it comes to these kind of things. Okay, so that's a bit of an introduction of a bit of a review of what we've done so far. Today we are going to talk about, I think I started talking about conditional analysis using Python. And then I think I also did talk about loops. I don't remember exactly where I ended discussions on these topics because I'm dealing with two groups. I might have ended it somehow with one group and a different way with another group. So what I want to do is kind of start it all over as um, a revision, and then it continues from where we have not really talked about. But before I do that kind of job, it's a good thing for me to ask if you have a question or you have something you want to bring to the class attention so that we discuss these things before we start today's work. Any such issues, you can unmute yourself and then you mention your name and you talk about what you want to talk about. So that's just about 2 minutes to do that quickly. Yeah, Joycelyn. Joycelyn, do you want to say something? Do you want to comment or ask a question? Just anything.
Sir, please, no question.
Okay. So then we have to start today's work. So let me try and open my application and then I'll share the screen with you.
Sir, please, people are unable to join.
Yeah, I think I'm trying to fix that problem.
Very much.
Ignatius, do you have your hand up? You can just go ahead, mention your name and talk, right?
Some people also live in.
No, please, they are not leaving. The network issue. Them trying to join back, so they are not getting access.
But they were recording it. That's you.
I think you should begin to see my screen. Do you see my screen now, please? Let me know if you see the screen.
Yes, sir.
Yes, sir, we can see.
Yeah, I can also see.
Yes, sir, we can see.
Okay, thank you.
Yeah. So, what we want to do.
They follow them. Yeah. Just on your data, then join Zoom. But I don't get email. You don't get Gmail.
Please, we can't see.
So just do that.
Sir, please, we can see. Thank you very much.
Please.
Yo, family, peace in mommy.
Don't forget. I know they like Zoom for myself too.
Hey, why need you know?
For my PC. Yeah. Mute them.
Abraham Hassan. Okay, so come back and let's start business. We are beginning with conditional analysis. And basically what conditional analysis means is that you will want to kind of proceed on a decision, whether the decision is to go right or left. But whether you go right or left is dependent on something happening or something not happening. That's the kind of decisions which we call conditional or condition-based decision or conditional analysis. A typical example, as I illustrated in class, is where maybe we want to provide some incentives to maybe our workforce, maybe our sales workforce. So what we are doing is if they're able to sell more, then we kind of give them some bonus. So what it means is that your qualification for the bonus is conditioned on you meeting some qualifying sales amounts. It's not just any amount that we pay you some money. Yeah. So such kind of situations, you can imagine more of such situations where your decision is based on some condition happening. So let's do an illustration straight away, how Python implements those kind of situations. I have this simple example here. This might not communicate any business meaning, but let's do this one in the meantime, and then we'll try to use some example which mimics a business case. So if you look at this code, the conditional analysis begins with a keyword if. It's just the normal thing that we do in real life. A conditional statement begins usually with if. If something happens, then we will do this or we will not do this. So it usually begins with the keyword if. So it's as natural as the way we do it in life. So you see this code, if, then what is the condition? If you come, then I'll give you this. So the condition is come. In the same vein, in Python, we say if, and then we add that condition. So in this case, what we are doing is if 11 modulo 2, this percent sign means modulo, and what it is doing is when we divide 11 by 2, we are not interested in the answer itself, but we are interested in if there is any residual, if there is any remainder. So we are asking if 11 modulo 2, if we divide 11 by 2, and the remainder is equal to 0, and see, this is equal to double of the equal sign. If that condition is true, so you put your colon here, that is the end of the condition statement. Then you press enter. When you press enter, your cursor will drop down 4 spaces indented, like you are seeing on the screen. Then you specify what happens if that condition is true. Just anything, specify it in code. To run it, it will just execute that code if the condition is true. If the condition is not true, you might want to do something if it is not true. Sometimes you might want to do nothing. So if you want to do nothing, then we don't need this else part of the condition statement, the if statement. But if your decision is a dual one, if it is true, you do something different. If it is false, you do something different. Then this becomes the structure of the if statement. If condition, colon, then I move down with 4 spaces indentation. Then I specify. So the first kind of block of code just beneath the if statement is the code that you run if the condition tests true. If it doesn't test true, then you have to use this keyword else. Else is doing something like otherwise. Else, colon. Then you drop down, you enter. Then it also indents about 4 spaces, not about, just 4 spaces. And then you specify what should happen if that condition doesn't test true. Okay, so we did this in class. So let's try to do something around the one I was saying. So let's say if the sales amount, so if So let's try to create some record of some sales amount. So we can simply do that with a list. So let's say sales, and we create a list. Let me try to zoom my screen so you can see. Then we have, let's say 1,000, 1,200. These are sales records for, or sales amounts made by some sales persons. 1,500, 2,000, and let's say 3,200. Okay. So we have these sales records, and we want to calculate bonus amount. So we can even do a list to kind of hold these bonus calculations. So let me create, let's say, bonus. In the real world, your design could be a bit different. This is just for demonstration. Bonus, and let's create an empty list. So what we are going to do is that we are going to do the calculation on these sales amounts if a certain condition is met, and the condition is basically if the person has met some qualifying sales amount. If that is the case, then we compute the bonus on all of the qualifying values and put them in the bonus list. Basically, that's our design. Okay, so let me come down and say if okay, so this one will require us to kind of have a knowledge about another thing. So let's say if sales 0, and I'll ask someone to kind of help us with the interpretation of this code. If sales and then square bracket 0 is less than, no, this should be greater than, is greater than or equal to, let's say, 2,000, column, then I come down. What should happen if this condition is true? We are going to go through this sales records and find this condition. In this case, I'm doing a simple demonstration. I'm kind of going to test for this value, the value at the index location 0 of the sales list. If that value is greater than or equal to 2,000, then do this. Just show us this calculation. Let's multiply that value by, let's say, 10%, so 0.1. Else, then anything at all. Else, we can print 0. Else, it means bonus is 0. When we run, it will test for the value here, the value at the index location of the list, the sales list. Test it for if it is greater than or equal to 2,000, and if that is true, it will multiply that value. So that's the meaning of sales. The same thing here, sales square bracket 0 times 0.1. Multiply it by 0.1. And it will show it to us. If that condition is not true, it will print 0. Okay. So you see 0 there, it means it kind of looked at the value at 0 index of the sales list, and that is 1,000. This is a small data set, so we can see it. This is 1,000, and it doesn't meet the condition. The condition is not true for that value. This is not 2,000, this is 1,000. So it skips the first code, it skips this one, and comes to the code where we said should run if that condition is false. Let's try to change one or two things so that maybe it will test true. So if that value is less than or equal to 2,000, of course, it is less than 2,000, so that condition will be true. And then logically, it will read it to be true, and then it will execute the code which corresponds to true. Okay, so it will calculate 0.1 on that value, and which is 100. Yeah, so that's basically the illustration of the if statement. It kind of is very powerful, but not on itself, really. Let's look at another thing in Python called the loop. Loops. Basically, we have two types of loops in Python. And we have the for loop, we have the while loop. We are going to talk about the for loop. That's the most popular loop, because the while loop can even be done through the for loop. Okay. So the for loop, a loop is simple like iteration. So kind of running through something in some circular sense. It might not be a complete circle. We talked a bit about it in class, so this part of it is going to be a revision. After which we will see how the for loop works with the if statement to do some magic, which we will need in our data analysis. So the for loop is so-called because it begins with a keyword for. And the basic thing we use it for is that if you have a list, if you have an array, a collection of some values. So in a business sense, it can be these sales values. And when we are talking about these things, the kind of picture we have to get is a typical business data set, which can be, for this particular sales records, it can be several thousands of values, What we may want to do in real life is that for each value inside the sales list, we will want to do some calculation. If you have to do such calculation, if the data set is so huge, it's about 500,000, it can even be 1 million of such values that you have to affect. And you can just imagine if you have to use a calculator and a pen for this exercise. It's going to be very tedious. And as someone who needs a job, if all you can do is to use a calculator and a pen, you are not suitable for this kind of job because you can't do it. Yeah. So this is where Python becomes very important. We will want to run through, let's say, 1 million of such values. 1,000, 1,200, 1,500, 2,000, 3,200, and we have 1 million of them. And for each one of them, we want to do some calculation. And even with that calculation, we are going to test for some condition. For example, in this case, these are sales values, sales amounts which are made by some salespersons. And we have, let's say, 1 million of such values. And we want to calculate 10% bonus if the amount meets a certain condition. If, for example, the amount is greater than or equal to 2,000, and then put them in a new column, in this case, in a new list. Okay. So this is how that code will be. The code follows a common sense approach. Python is not really difficult. So we are going to say that for each of the values in this sales list. So what we do is that since we are going to iterate through the list, we need some variable to step in to kind of be a placeholder for each of the variable. So this is how the structure looks like. For every sale value in the sales list. So you can use sales as the placeholder variable, which is going to kind of sit in for this when we are kind of doing calculations on this, after which it moves to sit in for this and this in that sense. So this is a temporary variable and it can be just any name. For the exercise we are doing, it will be more appropriate to use a word which is descriptive of what we are doing. So we say for sale, or we can say for amount in sales. This sales refers to this object. Column. Then we come down. If amount is greater than, equal to 2,000. Column. Okay, so the for statement ends with this column, and whatever we want to do is specified below that for statement with 4 spaces indentation. So what we want to do under the for statement is to, first of all, test the condition. So if amount is greater than or equal to 2,000, and that is, the if statement also has a structure of bringing a colon at the end of the statement, the if statement, and coming down 4 space indentation. Then we specify what happens. So if amount greater than or equal to 2,000, what should we do? Then in this case, we just want to, we want to kind of populate this list, the bonus. So we are going to say bonus. In the meantime, this bonus is empty. So bonus dot append, and we learned this method, which is applicable to list. Bonus dot append. Append what? Append the amount times 0.1. The meaning is this. For every amount in this sales list, if the amount is greater than or equal to 2,000, then that amount earns a bonus of 1%. So we are kind of collecting the bonus calculations in a different list called bonus. We have created that kind of object, and it has empty. It's empty. So that's the meaning of this code. And when we run, it has to do that job. So for now, you can't see anything because it has put the values in the bonus list. So we can go inside the bonus list and see what is there. So we see that in the bonus list, we have 200 and 320. So it's kind of only 2 values qualified for the bonus calculation. In other words, only 2 values met that condition we specified, the condition that the amount should be greater than or equal to 2,000. When we go to the sales list itself, you can see that this first value doesn't meet that condition because it is less than 2,000. And we are looking for greater than or equal to. This second one also is less than. This one also is less than. So it is only this one, the last two. 2,000 because it is equal to 2,000 and 3,200 because it is greater than 2,000. So it calculated 10% of 2,000, which is 200, and 10% of 3,200, which is 320. The beauty is this: if, like I said before, we have a very long list or a very long, a column of long values or plenty values, plenty rows. So a sales column, let's say we have a data frame, and then we have sales column. And this sales column has a lot of sales values, let's say 1 million of them. And then we want to calculate bonus on them, given that this condition is true. So you can just immediately see how this makes your life easier and how every company owner will be interested in using someone who has knowledge about doing things this way. Okay, so that's a brief introduction on the for loop and then the if statement, if conditional statement, and the combination of them, how they combine to solve some problem in business. Any questions? Any questions? You can unmute yourself if you have to ask a question. Then you ask your question. Any question before we progress?
Please, in the sales, this one, you see, it was the amount were 1,000, 1,200, 1,500. But when you rounded, you had something like 200.0 and 320. That's what I don't understand.
Your question is not a question. What about it that you don't understand? Do you understand what we are trying to do?
I think where he doesn't understand is the.
No, I'll come to you, please. I want to understand exactly what his problem is. Do you understand what we are trying to do?
Yes,
because
sir.
If you don't understand this 200 and 320, then possibly you don't understand what we are trying to do. Otherwise, you should understand. What we are trying to do is, if you have these values, these are sales amounts which are made by some salespeople. So let's say 1, 2, 3, 4, 5 sales reps. And let's say the first person made 1,000, the second person made a sale of 1,200, 1,500, 2,000, 3,200 in that order. And we want to give them motivation to work hard and sell more. And how we want to do that is kind of say that if you sell more, if you sell up to a certain value and above, you will give you 10% on that value. So these are the values that they have produced. We have to go and check if the values they have made, the sales values they have made, is up to that value that on which we will pay the bonus or above it. And we are saying that if you make a sale up to 2,000 or more, then you qualify for the bonus, otherwise you don't. So you want to do that calculation. Let's say we have 1 million of these values. Let's say it's a global company. Maybe 1 million is too exaggerating. So let's say 100,000, or let's say 10,000. So it's a global company of several salespeople. So 10,000 salespeople, and each one has his sales amount. So we have 10,000 of these values. And you have to go through each of the value to check if it is 2,000 or more. Then you calculate 10% as a bonus to be paid to the person. So 10,000, to do that by your calculator and your pen, in fact, that's not smart. So there is this tool that we can use in Python. We can use the combination of the if and the for loop to kind of do that job. And what we are doing is that we are saying that for every value, for every amount, or for every sale value, every sale amount, in that column, in this case, in this list, if the amount is greater than or equal to 2,000, because that's the amount which qualifies for the bonus. So we have to kind of test for that condition before we run the code to do the computations of the bonus. So if amount is greater than equal to 2,000, then calculate amount times 0.1. This is it. Amount times 0.1. And put that calculation in this column, in this case, this list. So that's the meaning of bonus.append. We are going to append amount times 0.1. And when you run, it will run through this list. 1,000, 1,200, 1,500, 2,000, 3,200. It will run through each one of them and test for whether that amount is greater than or equal to 2,000. If it is not greater than or equal to 2,000, no computations will be done on it. So if you look at it, this is what it returned, only 200 and 320. Because when it tests the condition, this one, it didn't meet the condition. So there's no bonus calculation for this one. This one too, there's no bonus calculation for this 1,200. There's no bonus calculation for 1,500. This one meets the condition because it is 2,000. So it will go ahead and compute 0.1 on 2,000, and that's the 200. And then it comes to this one, 3,200. Yeah, it is 2,000 or more. It is more than 2,000. So it meets the condition. So calculate 0.1 on it. That is 320. So that's the meaning of what you're saying. Are you okay?
Yes, sir. Thank you very much.
Okay. Any other issues? Okay. So let's talk about functions. Functions in Python, maybe two main types of functions. What I mean by two main types is that we have functions which are predefined. They're automatically there in Python, and you can take advantage of them. You can use them for your work. For example, see this one, print. It's a function. And it helped me to show the value for this calculation on the screen. You remember in our earlier days for this course, we used the length function to kind of check the length of some arrays. We also use the type function to check the data type of some objects. All of these kinds of functions are what we call built-in functions or predefined functions. They automatically deal with piping. That's not what we really want to talk about. What we need to know about those functions is that they are there. So you have to, when it becomes necessary to use them, you need to read more about them, know how they work, and the kind of arguments they take so that you can use them effectively. Today, what we want to talk about is the so-called user-defined functions. User-defined function. What it basically means is you are going to define the function by yourself. Let's say you want to do something. Python gives you that flexibility of defining a way that you want to do that and that suits just the way you want to do it. Okay. So this will be an introduction to user-defined functions. You might want to take it up and get deep into how it actually works. Let's say, for example, we want to create a function to maybe add two numbers. You can create a function for just anything, maybe a function to kind of write about yourself. What it is going to do is that, let's say the job you do every day requires you to be writing about yourself. I'm just using it as an example. It might not be too practical. So when you go to office, most part of the work will require you to type about yourself. And that can be some amount of text, and every day typing that amount of text. It can be tedious. Even if it is not tedious, it's too boring, too repetitive. The same thing, typing it again. You can give that job to the computer and go and rest. Go and think about something more intelligent, something more interesting. So let's say I want to define a function that produces some text. It could be a text which is about myself. So that anytime that I want to write about myself, I call that function, and that function kind of spits the text about myself. That's the job. I only type few things that is calling the function, and then the function spits the whole bunch of text. This is just an illustration of what functions can do. In a more business setting, in this case, management accounting, you might want to create a function to do some computations, sometimes a little bit complicated computations, which the predefined functions may not be able to handle or are not designed to handle. So that's where you might want to create your own function. For this class, we are going to show you the basic of how it works. You will have to kind of learn and practice and play. Don't be afraid of making mistakes. Every learning begins with mistakes. So if you want to be an expert from the beginning, then you will never be experts. It takes you to be a novice, make mistakes, crawl. When you are crawling, you kind of have your knees, you give some problem to your knees. When you pass the stage of crawling and you can't even just walk straight away. You will have to learn to stand, and you'll be jerking, you'll be falling down, and then you will master the art of standing. It will be difficult to even make a step. You make a step, you fall down. Gradually, you walk. And that's how learning also is. So let's see the beginning, the crawling, maybe up to standing, and then you take it up from there, and then you become a master. Some time to come. When you want to define a function, just like all of the things that we have seen, the if and the for loop, you bring some keyword. For example, the if statement begins with the keyword if. And if you're using a notebook, you have a nice way of saying that this is a keyword. It has a different color code. So the keyword for defining a function is the word def, maybe def for define. So def, then you bring a space and then you type the name of your function. So let's say in this case, we want to create a function that types about myself, that reproduces some text about myself. And every function has, the function behaves like, okay, I have my mouth open, put in something and let me process and gives you some output. So kind of see the open closing parenthesis as the mouth of the function, which is open to accept what you put in there for it to process and give you an output. But it's not all the time that you have to put something in the parenthesis. You can have an empty parenthesis and so the function will work. So in this case, we'll do that thing. So you say def, the name of the function, open closing parenthesis, colon. So it's similar in structure to what we have discussed previously. Then I come down. So this is what I want to specify if the function is called. Whatever in the world that I want to happen, if the function is called, I need to specify it in this space. So let me go and copy some text. I'm just copying any text for illustration, right? So I'm going to copy some text. And say print that text anytime I call this function. So Control V. Some long list. Okay, so because it is a text, what I should have done before is to put it in quotation. And inside that text, I think we have a case where there is a single quote inside the text. So what I do is to rather use the double quotation and put the whole of this inside it. Sorry, so print, double quote, Control V. Okay, so let me just run this. When I run, it will kind of create this function called myself. And then the job of the function is that it should produce this text when it is called. So let's see the error. Okay. The structure of the text is, okay, so this is better. So let's create it. Yeah. So the function is created and the function's name is myself. So anytime I call this function, the job we give to the function is that, well, if you are called, print this. So when I call the function myself, open closing parenthesis, that's the function. Yes, the function produces that, just as I put it there. Yeah, I mean, what may be the need for doing this kind of texting, like I said earlier, maybe you always kind of type some repetitive text all the time. You can create a function and put that text inside it, and you just call that function and it reproduces the text for you. That's more handy, that's more time-saving, that's more smart. But it might not be what we'll be using it for in businesses. Mostly what we do in business is calculation. So let's say we want to create a function to do some calculation. Basically, even though we have a function that does that sums numbers, that multiplies numbers, and so on and so forth, let's learn by trying to create something around those things. So a function to add. And let's call that function, let's say, add. And in this case, it's more appropriate, and it's going to be the way that normally things gets done, that the person who is calling the function will have to produce the number that he add. So let's say 2 numbers for a start. So I'm going to say, I'm going to pass some parameters in the function, which is going to step in, be a placeholder for the values. So we are going to accommodate only 2 values, add 2 values. So I'm going to say x, so x is a placeholder variable, y, which is going to stand in for the values that the user may provide. So def, the function name is add, and it takes 2 arguments. So specified it's with the x and y parameters. So colon, I come down, and then this is where I specify what happens when the function is called. What will happen on x and y? So maybe print x plus y. X plus y. And when you call that function add and specify any 2 numbers, it will add them. So let's create a function and see. So add, and I'm going to do, let's say, 10, 100. Yes, it will add them. Another time, let's say you call the function and you do -10, let's say 1000, for example. I mean, you don't need to really worry about the accuracy. That's the job of a computer. It will actually do it correctly for you. All you need to know is to learn how to do these things. And then the main job, the actual tediousness of the work, is taken away from you. It's given to the machine to do. So that's a function to add numbers. You can create a function to divide numbers, a function to multiply numbers. It follows the same logic. Sometimes you will want to, okay, let me talk about the issue of positional arguments. When we're creating the function, these x and y are called parameters of the function. So when you call the function, you will have to say, okay, the x is this value, the y is this value. So when you are passing these values, which is going to represent the x and y's, we call them arguments. But at the function definition level, these x and y are called parameters. But you can use parameters and arguments maybe interchangeably. When you do it like this, we call the x and y, or in this case, 10 and 100, we call them positional arguments. Their position is kind of entrenched. It's kind of established. You can't swap their positions. So if the calculation matters about what x should be and y should be, when you interchange them, it can be a problem. Then you need to know exactly that the first one should be x, the second one should be y. But in real world, sometimes when you are typing, you just want to type. I can type y first, I can type x later, and it should still work it correctly. In that case, you will have to use what we call keyword arguments. So if you are specifying the function, so let's say, let's create another function. So def, let's say subtract. You are doing a function to kind of subtract one number from the other. So def, let me call it subtract. Okay. So in this case, if I do x and y, they are positional arguments, and then x, the first one is always for x, and the second one is always for y. If I want to do it such that I can change their positions, then I have to use keyword arguments. In that case, I would say x equals x, comma, y equals y. The meaning of this is that when I'm kind of calling the function and passing the arguments, I will use the keyword x and then assign a value. The keywords y and then assign a value. Because I'm going to use the keyword x and y, then it doesn't matter which one comes first and which one comes later, because y is y, and it knows that, okay, y, even though it came first, this is y, right? So I do, let's say, y print. It can be in any order. I'm doing y minus x. You can do it x minus y. It doesn't matter. Okay, so this is it. And if I have to use a function, I call the function's name subtract, open closing parenthesis. I can do x is equal to, it doesn't matter which one comes first. I can do y equals, let's say 100. X equals, let's say 50 and run. So it will do the calculation. Y minus x. I can call the function again, subtract, and say x equals 100, y equals 50. And it doesn't matter which one came first because you have defined their names, x, so x is this, y is this. Wherever they are, x is x, y is y. You can also do it like this. If you can decide not to kind of pass the argument with their labels x and y, but you have to know that when we're defining a function, okay, x was first, y was first. Maybe that's how it will see it. Let's try it and see. Subtract. Let's do 100, 50 and see. Okay, so it will take the first one. It's kind of, if you do it like this, it will kind of take the position of a positional argument. When we're defining the function, we put x first and we put y second. Because we are not attaching their names to x, in that case, the order doesn't matter. In this case, the first one will be x and the second one will be y. And then you said, when you pass these two numbers, it should be y minus x. So the first one, which is x, the second one, which is y, is 50 minus the second one, which is y. So that's what is giving you the negative 50. Any questions on functions so far? Any questions? Okay. So when we have it like this, the main thing we want to have our eyes on right now is the applications of them. You can have a data frame of, different columns, and some of the columns the calculation of some additional columns you want to add might be based on existing columns. For example, let's say you have a table of sales reps, maybe sales rep ID, their names, their sales amount, and you want to create a new column, which is bonus. Of course, the bonus column will depend on existing column of the table, basically the sales column. So you do that kind of computation like we have done. The bonus calculation will be based on a condition, so you merge the if, the for, and the if. You can also use some other functions to do that kind of thing. When we start chapter 3 going, where we do some calculations, where we have some tables for some data we have to process and make information available for decision making, we will be employing all of these separate tools as we have learned from day one till now. The textbook that you have contains a lot of rich explanations on how these concepts work. These concepts have been applied on some data to give you a sense of how it will work in the real world sense. So you have to kind of read that book as if you are reading the gospel, and you'll be fine. So if you don't have any questions, I'll give you the remaining time to continue your reading for the quiz. The quiz is going to happen on Thursday. And it's just about all the things we're doing in the classroom. So read well. The textbook is good. The internet also has a lot of information. Always have the mind of wanting to know something which solves a problem. You can't just school and the knowledge you will get solves no problem. That's a waste of time and your money. Okay, so that's a piece of advice I'll give to you. Learn with the mind of solving a problem. In that case, you will naturally understand what you are doing and it will solve a problem. And if you learn like that, you can score 100% in my test, because my test is going to gauge your understanding and the application of that understanding in problem solving. Okay, so thank you very much for your attention, and we will meet again. The video has been recorded, so it will be put on your YouTube channel for you to visit it if you want. I just saw some people wanted to record it. It has been recorded. I'll put it on your channel for you to access it. Okay, thank you.